Now that we've learned the measures of airport capacity and the factors affecting airport capacity, now we're going to dig deep into calculating airport capacity and estimating delay. And for these calculations, we will be digging deep into Advisory Circular 150 5060-5, which is in your reading assignments. Please have that document open and be familiar with it, especially with chapters 2 and 3 and appendices 1 and 2 as we go through this video. Well, we start by calculating airport capacity based upon the runway layout and the mix index. Mix index is determined historically and projected for future forecasting. In our scenario, that information is given to us. And then, using figure 2-1 in the advisory circular, we determine which runway layout is applicable to the airport. In our scenario, we're going to use runway configuration 3. Mix index is calculated by using the formula percentage of aircraft in Class C plus 3 times the percentage of Class D aircraft. In our scenario, we have 25% Class C and 5% in Class D, so applying that formula is 25 plus 3 times 5, that's 3 times the percentage of aircraft Class D, that equals 40%. 40% mix index. Transfer that number down to figure 2-1 in the appropriate place. Read the hourly capacity off of there, as well as the annual service volume. Now, in your course resources section, I developed a spreadsheet for you called Capacity and Delay Worksheet. And that is taken from this advisory circular, but it's there and prepared for you. As you make calculations, you can fill out the spreadsheet with the information to keep it organized and readable like this. Now that we know our annual service volume, we need to determine the annual demand. So we know the annual service volume. We need to now calculate the annual demand. How do we do that? Now, annual demand is in the next year, how many aircraft operations would we anticipate? Airports gather this data, gather this information from multiple different sources of historical and trend websites and information. This number is quite crucial for the airport to get right, so they do not overbuild or underplan. In our scenario, annual demand anticipated, it will be given to you as 250,000 operations per year. That's our anticipated annual demand for this example. Next, we need to calculate the ratio of demand to annual service volume. You do that dividing the demand by the annual service volume and you get 0.877. Put the results into the chart like this. And we can conclude that our demand is close to but not exceeding capacity, about 88%. So we're operating at about 88% capacity in our scenario. Does this mean that there is no delay? To the contrary. Next, we plot average delay per aircraft using figure 2-2 from the advisory circular. Now follow this closely if you can. Draw the the ratio is found along the x-axis. There's the x-axis and the ratio is found there. We said 0.87. So you find the ratio on the x-axis, go up into the band from there, and the bottom of the band represents the low delay per aircraft, and the top of the band represents the high delay per aircraft as an average in minutes. Note that this is the average per aircraft, spread over 250,000 operations. Some will have a far greater delay than 30 seconds, which is what we've come to in our scenario, or 2 minutes as the maximum average delay in our scenario. Many will have no delay at all. The way that you do that is you come across to the y-axis from the bottom and across to the y-axis from the top, from what you find from the ratio. So this tells us that spread over 250,000 operations in an entire year, the average delay per aircraft will be between 30 seconds and 2 minutes. Knowing that, though, reality says that some aircraft will have no delay at all, and many aircraft will have greater delay than 2 minutes. Some of them far greater delay than 2 minutes. But we're going to go ahead and work through our spreadsheet. So plot those numbers, the average delay per aircraft, and then we're going to take the average delay per aircraft and project that number to the actual minutes of delay over the course of the year. To do this, we take the low and high average delay per aircraft, respectively, and multiply those numbers by the number of aircraft we anticipate operations. So it's 0.5 minutes delay and 2.0 minutes delay. Multiply that times our expected annual demand of 250,000 operations, and we get to find out that we actually are anticipating, on the low side, an annual average delay of 125,000 minutes, or worst case scenario on the high side, 500,000 minutes of delay. So we plot the results in the spreadsheet, and in the next video now we're going to translate these numbers into meaningful data. So what does a minutes of annual delay really mean? How does that come down to give us meaningful data so that we can use that data to make airport development decisions? We'll cover that in the next video.